Okay. Let me know. Hopefully it's not full or something. Anybody found anything else that's getting you through anything? Or have you guys even looked? Do you guys even realize that you probably should?
Wait, look at what?
Look for additional resources.
Oh, yeah.
You have the free tutoring here, but sometimes that's not going to help out the most. Sometimes they get crazy busy. You have your hand up for a long time. Somebody had that experience yet? Have you been to the Mass Study Center yet?
Yeah.
Yeah? Are they doing okay over there?
Not too good.
It's alright.
They're
It gets
alright.
packed sometimes, but I do my homework there all the time. I love it.
All right, cool. I like it. And the tutors are good?
They need some better tutors.
So if you have a bad experience, I used to be in charge there, so it always makes me cringe when I hear that students having a bad experience. You got to fill out those evaluations. I mean, when I was in charge, and Sean's done this too, the guy in charge, he's fired some people because of problems, several bad evaluations, and he directly observed some problems, so he had to get rid of people. I mean, they're never going to make it get better unless they know what's going on. And if you say good things about tutors, then at the end of the semester, I always gave like a Starbucks or a gas card, especially when gas is really expensive, as a gift to the tutors who did really well, got the most good reviews, and of course I'd also directly observe them, because you could always have your friends come stuff the ballot box, really, so you got to watch out for that. But yeah, you can totally get feedback in the tutor center. If you don't, it's not going to change, or it's not going to continue to be good if you're having a good experience, right? But you guys have to find additional resources. The book that we picked isn't necessarily the best book in the world, right? Some of you guys might have that opinion right now. Yes?
My math lab has, so when you ask how to solve this problem, so the animate, you know how when they show the animation, it's good, but the terminology they use to describe this crap.
Oh, yes. That's what I'm saying.
I just don't.
This is what I'm saying.
It's the worst.
The videos could be good, it could be bad. They could make too many assumptions about understanding the words they're going to use. It could be somebody who's up there talking like one of my instructors would always, he was very monotone. He needs to stand up and do this all the time. And today we're going to talk about groups of numbers, and we're all like, he was the only one teaching this course, though. So you have these videos with people that
It's
are.
not the actual video. I didn't see the videos, but it's just the way you describe how to solve the problem.
Oh,
You know.
all right. Well, I can't say that. Yeah, that's another reason why I make it optional. But at least they have that built in.
Yeah.
Yeah.
It helps to a certain extent.
Okay. All right. So let's get into chapter 10. We don't do section 10.1. We get right into section 10.2. And let me ask you a couple of questions here. What is absolute value? Those lines. And what do those lines do? What do they mean?
Like anything instantly positive.
Okay, good. So if I had absolute value of -4,
Positive.
yeah, it's +4. If I had absolute value of 7, 7, right? Anybody know what physical idea the absolute value is based on? Why does this always come up positive?
From zero?
What about from 0? The
The
distance.
Yeah, there you go.
The distance, right? And I don't care if you're in front of me or behind me. I'm not going to say you're -4 feet away from me. That's weird. Are you in a black hole? Are you inside me? Get out of me, Bob. You know, that's you're -3 feet. That's that scene from a Total Recall. No? All right. I'm talking about the original with Arnold Schwarzenegger. So absolute value is based on distance. So of course, how far away from 0 is -4? How many steps away? 4. That's why the answer is 4. So absolute value is the most single-minded function in mathematics. It just says, if you ain't positive already, I'm going to make you positive. And the only thing, this is kind of a trick question, sort of, I guess. There's only one number it doesn't make positive, and that's the number that isn't positive or negative. 0. So 0, of course, how far away is 0 away from itself? 0. All right. So there's nothing amazing about that. So here's the weird question. I just want to make sure that we all remember what absolute value means. Now here's a weird-ass question. What is the absolute value of x?
1. Is there 1?
No.
Plus or minus
Infinity.
it?
We don't know what x is, right?
That would be infinite. Infinite amount.
Then you're saying that x is infinity. Now, I'm not asking you to tell me how many answers there could be, because how many things could x be?
Infinite.
An infinite number of things. I'm asking you, can you simplify that? And what is it based? What is it? The fact that we don't know what the number is. Why does that affect the answer? What did the absolute value do here? What did it do? Yeah, so what did it mathematically do to negative 4? How do you make a negative positive? Multiply it by? Good. So what the absolute value actually did, let me put this over here. So this is our research. Right? We're researching this weird-ass question, right? Absolute value negative 4, it was the opposite of negative 4. It multiplied it by negative. Does that make sense? But what did it do to 7? What did it do to 7? Did it do anything to 7?
No.
No, shit. So absolute value 7, it just left it alone. It stayed the same. So what is the dividing line for the absolute value definition? Where does it start to do something? When numbers become negative. I love it. Some of you guys are like, yes, dude, that's what... But I really want you to break this down. So I can't really answer this question that you know about yet. We can. But the answer is going to have how many parts to it? 2. Because it all depends on if x is positive or if x is negative. So let me write it like this. Absolute value of x equals. What if x is positive? If that number is positive, what does the absolute value do to it?
Leave it alone.
Doesn't do anything. Bless you, bless you. Bless you. Alright. So you guys with me so far? So if x is 7, the answer at the absolute value of 7 is 7. If x is 38, absolute value of 38 is 38. See, that's just beautiful, right? But if x is negative, that definition doesn't work, does it? If x is negative, absolute value of negative 2 is not equal to negative 2, right? Do you guys see that? So if x itself is negative 2, the answer can't be x. What does the absolute value do when the inside is negative? What do we say it does? Yeah, so if x is negative, if x is less than 0, that is what it does. And what throws people off is you look at this and you say, how the hell can the absolute value equal negative? This is not negative, is it? What is this? This is negative times what kind of number? Negative. What's negative times negative? Positive. So what this is really saying is, if it's positive, it leaves it alone. If it's negative, it changes the sign. And of course, that's what absolute value does. We're working towards solving equations and inequalities that have absolute values in them. We have to understand what the absolute value does to variables before we can start doing it with equations, right? All right, maybe.
Can we do one more?
This is done. There's nothing more I can do here.
No, I do.
Let me ask you this here. So let's take one level up here with absolute value by itself. If I said this, can somebody tell me, this is going to be a weird question because some of you guys might think this is the answer, but can somebody come up with a mistake you think somebody might make?
Negative 4. You would think it would be negative 4.
Well,
You can't have absolute values before making
To a positive.
that's what it's supposed to be. So that's the answer. So the right way to do this, is 3 minus 7 is negative 4. And absolute value of negative 4 is 4. Because the absolute values, what do they kind of look like? And they end up being in the same place in order operations. They look like parentheses that somebody freaking ironed or something, right? Oh crap, dude. So they're in the same place on the order operations. They're in the P level. They're way the hell up there. So you got to do inside them first, and then you do them, right? You change the sign of the number. So the mistake somebody would make, there's a mistake I see all the damn time, is I see that. Right? Because what is the student focusing on? The negative side. And they're like, well, absolute value makes everything positive. There you go. But of course, it's silly. I don't even know what number that is yet until I've done it. And then I know what number it is, and then I can do the absolute value. Do you guys? I'm trying to get you guys to never make that mistake.
Yeah.
That mistake doesn't make any sense. Where I understand it a little better is when I start doing stuff like, because now, can you put x and 7, can you put those together?
Yeah. No.
Yeah, I was going to say, if you can, you're better than me. Right? You got to teach me, master. But of course, the mistake I see, of course, is related to this. But I can understand it a little bit more here because you can't do shit on the inside. So that you're like, I got to do something. That's what I got to do. But that is a mistake, just as much as that was a mistake, right? What is x minus 7? Is it negative? I don't know. Give me a number that would make this number negative. Give me a value for x. Yeah, if x were 6, this would be negative, right? You guys kind of with me? And of course, if x was 8, this would be positive. So the absolute value does two different things. Well, what is x? I don't freaking know, right? Let me see if you guys can go this one extra step with me, based on what we did over there. So what's the dividing line for this? What value divides this? Why'd you say 6? Because it's below 7, right? So at 7, this would be 0. So what if x is at least 7? What kind of number would this be? Positive. So what would the absolute value do to it?
Leave it alone.
Leave it alone. So the answer would be x minus 7. Well, what if x is less than 7? Then the absolute value is going to change the sign of x minus 7. So it's going to change the sign of x minus 7. That's what it would do to it. Let's test this out. Right? And how would you do this? How would you simplify this? Negative x plus 7. Cool. So let's try this out.
Wait, so it's not x plus 7?
Totally not. That was a mistake. I really, really try to make this clear. If you write this on your notes, make it really clear to yourself that that is a mistake. Right? Just bang it.
So
Okay.
what you want us to write is the explanation below, right?
We're exploring absolute value right now. We haven't gotten to a problem you're going to have to do on your own. You guys kind of with me? I don't want you to freak out. You're not going to have to do and explain anything I'm talking about right now. And you're all like, well, why the hell are you talking about that, man? Because I want you to understand why it's going to happen with equations. What's going to happen, right? And actually, well, let's see. So if x is 6, like you said, then this is telling me that this must be true. Because 6 is less than 7, right? Let's test it. What happens when I put a 6 in? 6 minus 7 is negative 1. The absolute value of negative 1 is 1. And if I put a 6 in here, is it the same thing? Negative 6 plus 7 is 1. So they're the same. So it's true. So there's nothing amazing there. We knew that was going to happen. We've broken it down as to when the absolute value does something and when it doesn't do something. It depends on when this thing actually becomes 0. And that's the dividing line between negative and positive, right? Good and evil. Okay. So, let me do a problem like you guys are currently thinking about. You're like thinking, if you're me, I would be thinking, so what the hell am I going to have to do? Right? So let's start with an easy. So here's an equation with an absolute value in it. So that's actually an equation. There are answers to this. And you can tell me the answers directly. I mean, really what this is saying is, what do I put into an absolute value to have the answer be 4? So what could you put in there? Yeah, so x could be negative 4, or x could be 4. So notice how, and of course this whole thing, I'm trying to get you guys to understand, there will always be 2 cases when there's an absolute value in your problem. Let me say that again. There will always be 2 cases when there's an absolute value in your problem. Why? Because of all this stuff we've been talking about. There's always two cases. Because the absolute value is like, should I do something or not? I don't know. If what your variable is, I'm going to have two cases. Well, if it's this, it does this. If it's that, it does that. All right, maybe. Let's take one step up. Oh, let me do this. I'm going to do this two different ways. The visual way you never have to do, because the visual way, if I put anything in here that's more complicated than this, the visual way gets really hard. But for this problem, it's very easy. So I want to show you why it makes sense the answers you get algebraically. So I'm going to first show you a visual way to do it, and then we're going to do it algebraically. You should always do it algebraically, right? So again, what do these mean? What's the physical idea behind them? Distance from zero, really, right? But now that I've got these two numbers, what does the subtraction mean? When you subtract two numbers, you find out distance, right? So what this is really saying is, I want the distance between a number and 4 to be 3. That's a way to read that in English. Now trust me, if you're having any trouble with the approach I'm about to take, like I just said, you never have to do it. In fact, I'd rather you didn't. And again, you guys are like, why the hell are you showing us that? Just stay with me. All right? This is kind of nice. So I want the distance from 4 and some number to be 3. So here's 4. And so how many directions can I go to fulfill this? 2. I can go 2 directions, right? If I go up, how far up do I want to go?
3.
So I go up to 7. So 7 fulfills it. Of course, 7 minus 4 is? So of course the absolute value is 3. And how many steps down? 3. So I end up at 1. 1 minus 4 is negative 3. And the absolute value of negative 3 is 3. I love it. Cool. So that's the visual representation of what this problem is saying. And actually, those are the answers. So let's see what we get algebraically. If we don't get these algebraically, we can throw this section out. And whenever I say that, I know somewhere somebody's going, please not work for some reason. But it's going to work. It's too bad for you. So again, whenever you see absolute values in your equation, there will be 2 cases. One case will be the inside is that. Just like this case was, right? If whatever's inside is this number, then it's like true, of course. If whatever's inside is the negative of that number, then it's still true, of course, right? Because the absolute value would take the negative off. So either x minus 4 is 3, right? If I put a 3 in place of x minus 4, wouldn't that work? Or the inside is negative 3. All right, maybe. So whenever you have an absolute value equation, all the reasoning I've just told you about explains why we do this. But now you can kind of boil it down to the nuts and bolts. One case is you leave everything alone. You leave everything the way it is. If that is 3 already, then the absolute value is going to make it stay 3. Ooh, right? But if this is negative 3, then the absolute value will make it 3. So it could be one of those 2 things. Right? It's this, or it's that. And then you solve both of them. And what do you get? 7. Or 1. Just like we got visually, right? Yes, sir. Yes, ma'am. Either way. He's deferring to you. It's okay.
So whenever we do these problems, we find the absolute value of the number we're trying to find so that we can figure out the problem.
It's not that. You're saying, what would I put here? What would you put in here to make this equal 3? You would either make this 3 or you would make this negative 3. That's what you would put inside. So the inside, and what's the inside? X minus 4. If the inside was 3, this would be true. If the inside was negative 3, this would be true. That's it.
So it's just easier to put that on the number you're trying to find.
I love it. Exactly. Instead of trying to rewrite the absolute value in these 2 different ways, I actually just put the negative on the other side, if that's what you're thinking about. That's good. I love it. Yes, sir.
Okay, so I'm not sure if you already explained this or not, but what if the absolute solution of x is equal to a negative number?
Beautiful. All right, look at you getting ahead of me. So as we know already, I repeatedly have to defend math. And of course, I don't know if you believe me or not, that it's never math's fault that we get these extraneous solutions. And it isn't. And I don't know if I've explained it to you well enough. But if you start with a bogus equation, you're going to end up with bogus answers. I mean, it's not math's fault. What the hell can math do? So if I start with an equation that says this here, and you do the work, you will get answers. They will be wrong. And why would answers to this equation have to be wrong? What would you take the absolute value of to get negative 7? Can anything, what's the absolute value, always have to come out to be? It always has to come out to be positive. So this equation is bogus from the beginning. And we've seen equations like that end up saying 5 equals 6. And you're supposed to say no solution, right? There was some of you guys had a problem like that. Some of you guys had one that was all real numbers. Right? And some of you guys had a weird one that came out to be 0. But if you did the work, so the answer here should be no solution. And you could totally just stop right there and write that. Please do. That would be awesome. You should just kind of step back from the equation and say, this ain't never going to work. Right? Do you guys see that? I'll take that as a yes. 3 of you nodded your head. So, all right. If you do the work, though, what would the work look like? One situation is you leave it the same. Or what's the other situation? 11. So if you solve these, you get 2 answers. Of course, neither one of them work. If you plug them in, negative 9 plus 2 is negative 7. What's the absolute value of negative 7? Shit. 5 plus 2 is 7. What's the absolute value of 7? Shit. Right? So it doesn't work. Just like square root equations. We have to check it to see if it works. If you miss that there was no solution there. Right? You guys kind of with me? Okay, cool.
Wait, if you plug negative 9x plus 2, that's going to be negative 7.
What's these say? So if you check it, you get negative 9 plus 2. Absolute value of negative 7 is it true?
Oh.
No, it's not equal to negative 7, so it's not true. So please, don't feel like you have, don't do this work. If you notice this, just stop right away and say, there's no way this works, no solution. I already know already. So leave me alone. Maybe. Okay. So here, you guys try this. I'll shut up. Of course, now I start throwing the weird numbers into it. Alright, so let me catch up to you guys. So will there be answers here? Will there be answers? Yeah, so there's a reason to do the work. This is going to work, because the answer value could be 2 total. So what are the 2 cases?
4x plus 3 plus 2, 4x.
Okay, cool. And just always keep in mind, why does it make sense that there's 2 possibilities here? It's because I don't know what 4x plus 3 is. It could be 2, and that would work, or it could be negative 2, and that would work. So I've got to do both situations. When you solve this, what do you get? Good, negative 1/4, right? Can you make a 1? There it is, Jeff. So you subtract 3 divided by 4. Over here, you get negative 5/4. gas. All right, not too bad. Okay, cool. So here's the the thing to be careful about on these problems. You can't. Every single problem up here has had a similar property. So let me put another problem up here, and I can ask you what's different. What's different? Yeah. So I can't do what we've been doing like this until I get the absolute value by itself. Right? I can't do the two cases until I get it by itself. If you really think about it, what do I add to 4 to make 11?
7.
So this thing has to be 7, and then you can get your answers from there. You can't just make this 11 and negative 11. That doesn't make any damn sense. You got to isolate the absolute value first, and then you can make your two cases. So the first thing you
That's
do.
kind of like a clue right there. That's kind of like a clue giving you within the absolute value that equation has to be whatever.
Yeah, whenever you see absolute values, you want to get them by themselves. Anything outside the absolute value, get rid of it. So of course you would subtract 4, and get that, and then what are my two cases? Oh, yes, ma'am.
I was wondering if the number that you have where the 4 is, and you bring it over, if that makes that a negative, is that
Good, I love it.
solution?
If this was a 2, and I subtracted 4 and I get a negative 2 here, then I can stop. I know there's no way to make it work. So you can't determine if there's no solution. You can't start solving the problem until you get the absolute value by itself. So if at any point in your work it says absolute value equals a negative number, you can stop right there. But of course you got to get there first. That's another reason why you want to isolate your absolute value. It tells you, is there a reason to do anything? How you guys doing? Because there is a whole other way to do these equations. I don't know if anyone's ever been taught. You can actually replace this with a couple different things. But the danger is you miss, if this comes out to be a negative, you don't even realize that. You don't even know there was no point to do any work. I hate that. I'm like, I don't want to not know. So what are my two cases?
2x minus 5 equals 7. And 2x minus 5 equals negative 7. First one's 6, and the second one's negative 1.
Kick ass. So I really want you to realize the work here is not very difficult, right? Computationally, this is not difficult. But never forget why we're doing what we're doing. Never forget why it makes sense. Why are we making two cases? Don't just be memorizing it. Go, this is why it makes sense. Absolute value is going to do two different things. There's got to be two different cases because the absolute value has no idea what the hell's inside of it. I don't know what the hell that is. Shit. I'm a math man. I don't know what the hell that is. So what do you get? Yeah. So RB, you add 5, you get 12. Divide by 2, you get 6.
Negative.
Good. You add 5, you get negative 2. Divide by 2, you get negative 1. Yes. And you can check it like always. Right? Cool. Okay. I like it. So those aren't too bad, right? So here, just one more of those. And I'll tell you going in, this is even. Oh, what you got, Jeff? I don't know. Sure. Ah. Here's where people forget their order operations and you start doing neat, illegal things. Mathematically, I don't know what you're doing. In your personal lives, I'm just talking about mathematics. You should not have to do very much work for this. It should be very, very little work. Maybe two lines of work. Right? What's the first thing I should do? I love it. Can you do 4 minus 2 is 2? Why not? this is 4 minus 2 times, oh shit, order operation says I can't subtract until I multiply. And I can't multiply because I don't know what the hell that shit is. So I have to then realize my absolute value is not by itself. Subtract 4. So you get negative 2 times this mess equals 1. Is my absolute value alone yet? No, what do I have to get rid of? The negative 2, I want to get rid of it, right? Negative 2 times this, so how do I get rid of negative 2? Divide. So I get 3 minus 7x, absolute value equals negative 1/2. No solution, done. Right? So this is another reason this get your absolute value by itself, so you can see if there's even a point to do anything else. And in this case, there wasn't. It can't be negative. No solution. Cool. Alright. One more idea, and then we'll. This is also. There's 3 ideas in section 10.2. I'm going to do 2 of them, and then I'll let us out of here. You guys seem kind of antsy. Of course. You always seem kind of antsy. I can't blame you. Inequalities with absolute value. By the way, this is a stupid joke, but it's never stopped me before. I thought about this a while back, and then I looked it up, and somebody had already made a shirt out of it, so then, of course, I had to buy it. Absolute vodka, yeah. So I was in Seattle Airport, and I was wearing the shirt, and somebody finally laughed at it, and I was like, "Oh, you get it," because everybody normally just stares at you. Oh, no, it's a math. Oh, screw it. Yeah, I'm out of alcoholic. All right, so I just want to talk about one case of the absolute values, and then we'll head out. And I'll just do a couple quick little problems here. So right now we'll focus on less than, and tomorrow we'll look at greater than, because they're 2 different processes, those things. So let's see how this makes sense. And actually, let me do this. It's always a little weird when there's not another number here. It's 0 really, but let me do that. Let's do that. Now let's think about this visually, because that'll explain a little bit more what's going on here. So what does this say? This doesn't say I want the distance to be something. This says I want the distance between a number and 1 to be at most 5, right? And this is what I call a sandwich. This is what I call stay near me. We're going inside a scary haunted house. Stay near me. Let's break up. No, stay near me. Shit, I've seen it in the movies. You never break up. So this says I want from 1 to some number to be at most 5. So how far can I go up? Up to what?
5.
I can go 5 away from 1, but that gets me up how far? Up to what?
4.
No, if I go 5 up,
6.
2, 3, 4, 5. Yeah, get up to 6, right? I'm at 1. Here I am. I want the distance between a number and 1 to be at most 5. So I'm standing right here at 1. I want you to be at most 5 away from me. So if I'm going in that direction, you can go up to 6. If I'm going in that direction, how far down can you go? Negative 4. And now I can make it a little more formal. There you go. And that's why I call it a sandwich, right? There's your bread, jelly in between, or meat, or whatever you like to eat. Sandwich, right? Call it a sandwich if it's a good thing. You call it a sandwich if it's food. All right, maybe. So what this really gets down to, now watch, there's a better way to write the problem related to that answer. How far, so if this can be at most 5, it can go up by 5, or it can go down by 5, right? So that is the way to write the 2 cases. There are 2 cases here, right? That is less than or equal to 5, or it is greater than or equal to negative 5. Stay close to me, right? Don't go further down than negative 5. Don't go more up than 5. Stay close to me, right? I was thinking about, again, my kids, the kids with the ice cream and stuff. I don't want them to get very far away from me because they're not the brightest. They might fall into the canyon. Stay close to me, kids, right? Be a great dad. And what did you... Well, how do you think you solve this thing? I don't know if we've seen a three-sided threat thing here yet, right? It's a triple threat.
Add one on both sides.
Add one to all sides, right? So you just extend, normally we only have two sides, but the real general rule is if you add one to all sides. So if you add one to the middle, you better add one to the right side, you better add one to the left side, and what do you get? Exactly what we got visually, right? Yes, sir.
Does that still hold true if like your that rule or if your or is it the sign switches?
Yes, exactly. So if you multiply or divide by negative, you got to flip the sign. That's a rule of inequality. So the inequality doesn't care what's in it. It just says if you multiply by negative or divide, you got to switch. That's enough. Tomorrow we'll do the greater than, and the greater than situation I call the restraining order. That says the distance must be at least this. So that sounds like a restraining order. Stay the hell away from me. All right. I'll see you guys, not tomorrow, Thursday.
I did take the 7.6, was 7.5 and 7.7 together last Tuesday, my homework.
Yeah, I saw 7.5 and 7.7, but 7.6 was in there too?
Yes.
Okay, all right. I'll take another look.
What's up? Yeah.
What did you ask me?
Make a little note.
Oh, yeah. Oh, no, I don't know anything about it. I just want to